This video is all about systems of equations. And in a system of equation, you have two equations, and you're looking for the answer that will solve both equations. And an example of when you might need a system of equations is profit and loss. Let's say that you are going to sell an item, and it's going to cost you a setup fee of $150. Let's say you're going to make t-shirts. And your setup fee to make the t-shirts is $150. That's what it costs for you to create the graphics that are going to go on the t-shirt. After that, your cost might be $1.50 for every completed t-shirt. So you have a setup fee plus a per shirt cost. So your cost equation could be y equals $1.50 times X, or the number of shirts, plus $150. If you charge $3.50 for your shirts, your profit would be the profit would equal $3.50 times the number of shirts. At what number of items sold, how many shirts do you need to sell before your cost and your profit are the same? This is called the break-even point because you are not earning more or less than you spent. It is the coordinate pair x and y that makes both equations true. It is the answer to the system of equations. Those are some uses of the systems of equations, but now let's talk about some strategies to find the solution to a system of equations. And we can do this in several ways. My favorite way is substitution. So I'm going to write two equations. I've got 11, whoops, let me use black. 11x, let me try that again. 11x plus 9y is equal to negative 20. And my second equation is x equals negative 5y minus 6. We are going to look for if there is a solution or an x and y combination that will make both of these equations true. And in order to do this, what we do is we substitute the value of x into our original equation. And we have the value of x right here. This negative 5 minus 6, we don't know the value of x in a specific number, but we can replace x with the expression negative 5y minus 6. So what I'm going to do is I'm going to substitute x with negative 5y minus 6. And then I'm going to continue the first equation. What I'm doing is I'm taking this equation, and anywhere that I see an x, I'm going to replace that with negative 5y minus 6. Now I can use the distributive property. 11 times negative 5y is negative 55y. 11 times negative 6 is negative 66. Now I can continue to solve this equation, and I can say 55y plus 9y would be negative 46y minus 66 equals negative 20. Now I'm going to add 66 to both sides. And I'm going to say negative 46y is equal to negative 40 or positive 46. And when I divide both sides by negative 46, I can say y is equal to negative 1. Now I can take this y is equal to negative 1, and I can substitute back up in the other equation, and I can say Now I'm going to look at this y, and anywhere that I see a y, I'm going to replace it with -1. X equals -5 times -1 minus 6. X equals 5 times -1. -5 times -1 is 5. 5 minus 6. So I have a value for x and I have a value for y that should make these equations true. Should make both of the equations true. You want to find out if it does? Let's do. 11 times -1 plus 9 times -1, I'm trying this equation here, should equal -20. -11 plus -9 equals -20. It checks. Let's try the other equation. X equals -5y minus 6. So I'm going to replace x with -1, and I'm going to replace y with -1. And -1 equals -5 times -1 is 5. 5 minus 6 is -1. It checks. -1, -1. If x equals -1 and y equals -1, then both of these equations are true. That is a solution to a system of equations. Do they all have a solution? Let's find out. Let's try a second one. Okay, so our second equation reads 5x minus 3y equals -4. Y is equal to 5/3 x plus 6. And if you're familiar with the standard form of equations, you're already seeing a problem. But let's carry it on. So we have a value for y. This 5/3 x plus 6 is equal to y. So I'm going to take this 5/3 x plus 6 and I'm going to replace y with that expression. So I have 5x minus 3 times 5/3 x plus 6 equals -4. I am solving for x first by substituting y with the expression that is equivalent to y in the second equation. Now we're going to use the distributive property. 3 times 5/3 is the same as 3 times 5 is 15. 15/3 is 3. -3 times +6 is -18. 5x minus 3x. Oops, I'm sorry, that should be 5x. I apologize. 3 times 5 is 15. 15/3 should be 5x. So now look what happens. 5x minus 5x is 0. -18 equals -4. -18 minus -4, there is no solution. There is nothing I can do to make this equation true. So there is no solution, which actually means that these two lines have the same constant of proportionality, and if we were to graph them, we would find that these two equations have the same slope, which means they will never cross.